Alright, so last lesson for chapter 9. This is on graphing linear inequalities. So take some notes here, right? You can write in your book here or wherever. But when you see that equal, if it's greater than or equal to or less than or equal to, it's going to be a solid line. If it's greater than or less than, it's going to be a dashed line. This means solid means the solution is on the line. Or above or below, but the solution, and when there's not an equals, it means that the solution can't be on the line. That's why you do a dashed line, right? So that's what that means. I'm going to write that down. And then the shading, if it's greater than or greater than or equal to, you shade above the line, which means it's on the line or above the line. Here it just means it's above the line. And then when it's less than or less than or equal to, you shade below the line, and just, above the line or below the line. And it doesn't matter which way it's tilted, right? So pause and get that written down. So here, first one here. Here's your skill check on that page. And so if you have this inequality, you're gonna shade below the line, and it's gonna be a solid line. So just you pretend like that's an equal. You're just going to graph the line y equals x plus 1, and then it's going to be a solid line, and you would shade below the line. Right? Number 2, it's going to be above the line, and it's going to be dashed. That means it's not on the line. The solution isn't on the line, it's just above. Number 3, it's above the line, and it's dashed. It's not on the line. So you graph that line, pretty easy graph. We'll do this in a second here. And number 4 here, it's going to be above the line, and it's going to be a solid line, and this is going to be a negative slope because it's a negative slope. So we're going to graph. So there's your answers for that. And then, skill check on page 385. So here's your equation, or here's your inequality. So you just go to graph the line. I'm gonna just put my 1 over 1 here. So I go up 1, put a dot. I go over 1, up 1. Now I'm not gonna do a solid line. I'm gonna do a dashed line because it doesn't equal, and I'm shading above the line. That means everything up here, any point up here, is a solution. And the way you test is just do 0, 0. So this shouldn't be a solution. If I plug in 0, I get 0. And if I plug in 0, is 0 greater than 1? No, that's false, so that means it's not a solution. If it's not a solution here, it means it is a solution there. So you can prove it by the opposite way. Anyways, number 2. So again, I got my 3 numbers. I'm gonna go up 3, I'm gonna go over 2, up 1. It's a solid line, and I'm shading below. And if I did 0, 0, I could go 0 is less than or equal to 0 plus 3. Is 0 less than or equal to 3? That's true. So then that's where I shade. If it's true, so anything below is true. And on number 3, now if it's not y equals, or if it doesn't start with y, then you got to solve for y. Put the x first. And so here's my 3 numbers. I'll put a 1 here and then a 1. So I went up 2, I went over 1 and down 1. It's a solid line, and I'm shading above. And again, if I do 0, 0, this should be false. If I plug in 0, is 0 greater than or equal to 2? No, that's false because that's why it's not here, so it's here. And number 3, again, or 4, I subtract x from both sides, and then when you divide by -3, that flips the arrow. And -1 divided by -3 is 1/3. 12 divided by -3 is -4. So anyways, here's my 4 numbers. I went down 4, Bob's $4 in the hole, and every 3 days he's saving $1. It's a dashed line, and I'm shading below. So again, I could do 0, 0. 0 is not less than -4. So yeah, you don't shade here, you shade below. Anyways, so that, there it is. Just have your, I'll back that off. You can have that for double checking everybody.